Okay, next circle theorem then is the circle theorem that says angles subtended by an arc in the same segment are equal. So what we're saying here is if we pick 2 points on the edge of our circle, what you'll notice is if I were to do this, I'm splitting my circle into 2 segments, a minor one down here and a major one up at the top. I've got these 2 different segments. I've got the little one and this big segment, the major one. So from these 2 points, I can join the 2 points touching the edge of the circle, either going down to the bottom or I can go up to the top. And as long as I keep going in the same segment each time, the angles will be the same. So if I were to go up to the edge of the circle and down to that point, this angle will be exactly the same as if I were to go, say, out to here and down to that point, this angle. These 2 angles will always be equal. Okay, next circle theorem then is that opposite angles in a cyclic quadrilateral add up to 180 degrees. So a cyclic quadrilateral, what we mean by that is a quadrilateral where all of the corners, all of the vertices are on the circumference of the circle. So it's basically any quadrilateral you can draw where all the edges are on the center, or on the circumference, sorry, not the center, on the circumference of the circle. In this one, this center doesn't matter. It doesn't make any difference where the center is. And what this rule says is if you pick any 2 angles, so we have this one and this one, these 2 angles will add up to 180 degrees. And the same if you were to have chosen these 2 angles, these would also add up to 180 degrees. These 2 have the same rule. So the opposite angles will have a sum of 180. Okay, last circle theorem for today then. So 2 tangents drawn from a single point are the same length. So what that's saying is if you pick any point outside the circle, so let's say I'm going to pick this point over here. If you were to draw a tangent from that point, there are 2 tangents you could draw, aren't there? There'll be one tangent that just hits here, say, and there'll be another tangent that just hits here. So we've got these 2 tangents. And if you look at them just up to this point where they hit, these 2 crossing points here, these 2 lengths will be exactly the same. And what this comes in useful for is that you also know that these 2 are both radiuses. A radius and a tangent meet at 90 degrees. So you form, if you were to cut it like that, this forms 2 congruent triangles. So congruent means they're both exactly the same size, same angles. So these 2 triangles, I've split this into, are identical. So the angles are going to be the same on either side, which might help you with some of your working out.